All right, imagine pointing one of the most powerful digital cameras ever built at the night sky and just letting it watch, over and over again. That's basically what astronomers have been doing with the Vera C. Rubin Observatory, and it has already paid off in a big way. At the center of this observatory sits a gigantic camera called the LSST, and thanks to it, scientists have discovered an asteroid named 2025 MN45 that's doing something pretty wild. This thing is huge. It's about 710 meters wide, which is roughly like lining up 8 full-size football fields end to end. But the size isn't even the craziest part. The asteroid spins once every 1.88 minutes. Yes, less than 2 minutes. For an object that large, that's honestly kind of unbelievable. So how did they even figure that out? Over 7 nights in April and May of 2025, the camera kept taking repeated 40-second photos of the same regions of the sky, adding up to around 10 hours of observation. Astronomers weren't just looking for movement, they were watching for tiny changes in brightness. As an asteroid spins, sunlight reflects differently off its surface, making it flicker slightly. That flicker creates what's called a light curve, and from that, scientists can calculate exactly how fast it rotates. The project was led by astronomer Sarah Greenstreet from NSF NOR Lab, and the results were published on January 7, 2026, in the Astrophysical Journal Letters. This is actually the first peer-reviewed scientific study using real data from the LSST camera. Out of 76 asteroids with reliable rotation measurements, 16 were spinning unusually fast, and 3 of them completed a rotation in under 5 minutes. But 2025 MN45 took the crown among all asteroids larger than 500 meters. Here's why that matters. Most asteroids aren't solid rocks. They're more like floating piles of rubble, loose stones and dust held together only by gravity. If something that big spins too fast, it should literally tear itself apart. The fact that this one doesn't strongly suggests it's incredibly sturdy, probably solid rock. Scientists think it may be the leftover core of a much larger asteroid that was melted and shattered during a massive collision billions of years ago. All of this is happening just as the observatory prepares to begin its massive 10-year project called the Legacy Survey of Space and Time. Even before officially starting, it has already found thousands of solar system objects, including more than 1,900 previously unknown asteroids. Researchers say discoveries like this are exactly what they were hoping for once the telescope is fully up and running. Fast-spinning asteroids like this are basically time capsules. Their rotation tells scientists about the ancient history of the solar system, how objects collided, broke apart, and evolved into what we see today. Until now, super-fast rotation had only really been observed in tiny, near-Earth asteroids. The ones in the main asteroid belt are much farther away and fainter, so we just didn't have the tools to study them this precisely. Now we do, and if this is what the Rubin Observatory is finding before its main mission even starts, we're probably about to learn a lot more about our cosmic neighborhood than we ever expected.